Welcome to solverfy.
Let me draw the moon and the satellite. Let's say this is the moon and this is the satellite. The satellite is close to the moon, and this is the orbit of the satellite. The satellite is going around the moon. Satellite is going round the moon. And let's say the distance between the moon and the satellite is r. Let me show moon by m and the satellite by s. Now, the orbital velocity of the satellite with respect to moon is v is equal to root g r. This is gm, gravitational acceleration on the moon. And r is the distance between the center of the moon and the satellite. Now, a probe is fired from this satellite in the opposite direction. In this direction, a probe is fired from the satellite, and the velocity of the probe with respect to the satellite is also root g m times r. Now, the tricky part is to find out the velocity of the probe with respect to a person who is sitting on the surface of the moon. Now, let's find out the velocity of the probe with respect to a person who is sitting on the moon. Well, a deeper thought tells us that the velocity of the probe with respect to the person who is sitting on the moon is zero. It is zero. V with respect to the person on the moon is equal to 0. Therefore, the motion of the probe will be one-dimensional. It will start falling toward the surface of the moon. It will have a vertical path. It will travel in a straight vertical path, and eventually the probe will fall on the surface of the moon. This is one part. In the second part, we are asked that what would happen if the velocity of the probe is twice the velocity of the satellite with respect to the satellite? What would happen if the velocity of the probe is 2 times of the velocity of the satellite with respect to the satellite? This is very important. So this velocity is with respect to the satellite. This velocity of probe is with respect to the satellite. Well, then with respect to this person sitting on the moon, the velocity of the probe would be, in the second case, root g m r. The velocity of the probe in the opposite direction will be equal to the velocity of the satellite, and this will pose a danger because the probe will also orbit around the moon in the same radius, and the probe and the satellite will collide at a certain point, and both probe and the satellite may fall onto the surface of the earth due to the collision, or the parts of the collision may escape from the orbit. Either can happen. So, end of the problem. Thank you so much.